Hi, 11 Max 1, champions of South Sydney High School. This lesson is graphing polynomials, and I wanted to record this so that you've got an opportunity to look back over if you find that helpful. Well, we've done graphing polynomials before, but here we'll look at the different terms of the polynomial and how that affects the shape of the graph, how we can use that information from the different terms of the polynomial. So let's have a look at that. There's an example here, and I want to take that at a high level. I don't want to go through in detail the maths, so the next few examples we'll go through in a lot more detail. And you can see here the step-by-step approach to graphing the polynomial. Factorize is the first, and in this lesson, all of the polynomials that we graph will be factorized, and then in future lessons we'll look at different techniques we can use to help factorize polynomials and how that helps us graph those polynomials. Factorize, that allows us to see the zeros. So you can see here px, x plus 2 cubed, x squared, x minus 2, x plus 2 cubed, there's a 0 at minus 2, x minus 2, there's a 0 at 2, and the x squared, there's a 0 at 0. Okay, finding the zeros, and then the multiplicity of the zeros. Multiplicity, that means that the power of the term or the factor that contains that zero. So here, x plus 2 cubed, the power is 3. The multiplicity of that 0, so that's minus 2 is the 0, and the multiplicity of that 0 is 3. Okay, why is multiplicity important? If we think about, let's say, x cubed, and I'm just going to move my writing zone over. If we think about x cubed, you know the shape of x cubed because we've dealt with that before. If I go x cubed, and I'll just put in a quick axis here, and we know that x cubed, I might just change the color on that, goes from when x is a very high value, x cubed is high, we go through a point of inflection, and then as x goes negative, x cubed goes negative, and I'll just put that in as x cubed. So 2 cubed is 8, minus 2 cubed is minus 8, and we go through a point of inflection. We've dealt with that before. If we're talking about negative x cubed, and I'll change the color on that one, then we flip it round the other way. Negative x cubed, we've still got our point of inflection, probably should be drawn a bit flatter than that. If x is very large negative, negative x cubed, let's say minus 2, x cubed is minus 8, but then minus 8 is plus 8, and similarly 2 cubed is 8 and minus 8, and so it's flipped around the other way. The thing is that when you look at the shape of the polynomial around that zero, around that term, it looks the same as x cubed on its own. So we can see it, there's a 0 of minus 2, and it's of the negative form. We'll look at that in a second, but we go from very high through that point of inflection and then come down, and that's when other terms of the polynomial start to kick in. But when you're very close to that root, this polynomial behaves like an x cubed. And similarly, when you're very close to the root 0, the polynomial behaves like an x squared. And remember that the x squared is either concave up, a u, or concave down, an n. In this case, it's concave down, an n. And again, when we're close to that 0, which is 0, the shape of the polynomial looks like the shape of an x squared term. So that's why we care about the multiplicity of the zeros. The final 0 is a 2. It's a multiplicity of 1. So it's a little bit like a straight line. It cuts straight through the axis, straight through that 0. Okay, and we won't do the table of values here because we'll do that in the next example. You're used to using a table of value. Leading term. Why is the leading term important? And here px, I've multiplied it out. It's x6 plus 4x to the fifth and so on. And you don't need to multiply it out to see that leading term, because you can just notice here that the leading term is going to be an x cubed. If you multiply this out, there'll be lots of factors, but including x cubed times an x squared, that's x to the fifth, times an x, which is x to the sixth. So the leading term here is x to the sixth. And that leading term defines the shape of the polynomial when x is very small. So x to the 6 is an even power, so the polynomial is going to go very large and positive when x is very small, or very, very large negative, if you like, a very small amount. And when x is very large, again, that leading term x to the 6 is going to be very large. So that tells you a lot about the shape of the polynomial. Let's have a look now at, we'll look at this in a little bit more detail with a table of values next, and then we'll do some more examples. So let's go to the next page. And I've reproduced that checklist, the factorize, which at the moment we're factorized for everything, the zeros and multiplicity of the zeros, the leading term, and the table of values. So let me just check where the pad is so that we can move it across and make some marks here. And here we go. Here's that same px, x plus 2 cubed, x squared, x minus 2. Only this time we've filled in a little bit more information. So you've got the zeros, minus 2, 0, and 2. And in fact, the y-intercept is also the 0. So we don't have a separate calculation for that. And just to give an idea of the shape of the polynomial between those zeros, between 0 and 1, and if you put in that x equals 1 into the px equation, you'd get minus 27. You can use your calculator for that. You could stop the recording and use a calculator if you want to check that. And similarly, minus 1, we get f of minus 1 is minus 3. Plot that, and you can see, as we said before, x equals minus 2, it's a cubic. We know that we go from positive to negative. We know it for two reasons. Number one, because the leading term is an x to the 6. The leading term is an x to the 6. X to the 6. And so it means it goes from positive to negative. We also know that we can see here when you do f of minus 3, it's 45. When you do f of minus 1, it's minus 3, and so on. So now we're going to have a look at a couple of examples. And the first example here is x minus 1 squared, x minus 2. I've reproduced the checklist here. I've changed it slightly. I've just brought table of values up ahead of multiplicity of zeros. So let's have a look at this. We're already factorized, so we can easily see the roots, and the roots there are x equals 1 and x equals 2. And the y-intercept, if we make x equals 0, then y equals minus 1 squared times minus 2 equals minus 2. So we can put that in, and let's just label that. That's y equals minus 2, and they're the two roots 1 and 2. Table of values. So we put in our intercept and our x equals 0. There's our roots. And there's minus 2 here. And we want to know the values in between the roots. Well, we know what it is at 0, so we don't need another 1.5. But we do need to know a value, let's say at 1.5, so we can see what happens between these two zeros. And we can put in a value at 3 to see what happens up here. And let's come down here. P of 1.5 equals 1.5 minus 1 is 1/2 squared times 1.5 minus 2 minus 1/2 equals minus 1/8. I'll just put it up here actually, equals minus 1/8. And clear up that one. And P of 3 equals 3 minus 1 squared. which is 2 squared times 1 equals 4. So P of 3 equals 4, and P of 1.5 is minus an eighth. So we're just about ready to draw. Let's just check the shape. The multiplicity of the zeros, x minus 1 squared, that's a multiplicity of 2. So we know that the shape here is concave down, or an N shape. And we know the x minus 2 multiplicity of 1. So we know that it's going to cut through and head up towards that value 3, 4. And what do we know on the x is negative on the left side of 0 minus 2? Well, what's the leading term? Let's have a look at the leading term here. X squared times x. The leading term is x cubed. So we know that it's going to be negative if x is negative, and it's going to be positive as x increases, just like an x cubed. And so that now gives us completely the shape of our graph. So let's draw that in, and you can see now the shape of the graph. We go from negative, we go around to this 0, we dip down here, and then head towards that point 3, 1. And there's the shape of the graph. P of x equals x minus 1 squared x minus 2. So now we're going to go to example 2, and you can keep watching straight through, or you might want to pause the video, try a few yourself, and then come back to example 2. It's more complicated, but really it's exactly the same thinking and exactly the same steps. So let's work through this. We've got the checklist here, factorized form. We can read off our zeros, and the zeros are x equals 2. So let me just turn on the pen and show you that 0 at x equals 2. We'll look at the next 0 is x equals minus 1, and x equals 1. Okay, and the next value we want to look at is the y-intercept. So when x equals 0, y equals, when x equals 0, y equals minus 2 times minus 2 squared times 1 to the 5th times x equals 0 minus 1. And that equals minus 2 squared is 4, minus 8 times 1 times minus 1 is plus 8. So the y-intercept, 0, 8. Put the 8 up there. And now let's look at our table of values. We've got, put it up here, 0. I should put minus 1. We've got 1, and we've got x equals 2. So there's our 3 roots. There's our 3 roots. There's our y-intercept. And now in between those roots, we want to have a look at, and I'll change the color for this. We want to have a look at, let's say, x equals a half, x equals 1.5, and x equals 3, so that we can get an idea of that shape between the roots. And then we can go and have a look at the multiplicity of zeros in the leading terms so that we can form that shape properly. So let's calculate those additional points. And we've got, I'll do it down here, we've got q of a half, and we go back to the q function, minus 2 times a half minus 2 is minus 1.5 squared times half plus 1 is 2.5 to the power of 5. And you can see it's going to get big very quickly, and x minus 1, or at least big negative very quickly. Let's call it small very quickly. And a half minus 1 is minus a half. In fact, it's negative times negative, so it's big positive. Okay, I put a formula in Excel so that we can do that calculation quite quickly, but you can pick up your calculator and do that. And if I go x equals 0.5, 0.5, f of x is 17.1. So I'll put 17.1. That's positive. Negative times negative is a positive. Okay, q of 1.5. And again, I put the calculation in Excel, so I'm going to do that very quickly. You can stop the video and try it on your calculator. We've got minus 2 times 1.5 minus 2 is minus a half, all squared, times 2.5 to the fifth, 2.5 to the fifth, times 1.5 minus 1, that is half, equals. And now what we can see is this is positive, this is positive, this is positive, and this is negative. So overall negative. Q of 1.5, I put 1.5 is minus 24.4. I'll put that one in here, 24.4. And then Q of 3, and I'll just make this a little bit smaller here so that we can fit Q of 3 and make it, here we go, a little bit more. All right. Q of 3. And what do we do here? Equals minus 2 times 3 minus 2 is 1 squared, times 3 plus 1 is 4 to the fifth. That'll get very big, times 3 minus 1 is 2. And you can see plus, 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 it goes to very big minus. And Q of 3 is minus 4096. Minus 4096. Okay, let's put those points in here. So we've got Q of a half. Q of a half is 17, so we've got a very big positive. We've got Q of 1.5. Q of 1.5 is a very big negative. I'll just put a little x there. And Q of 3 is, again, Q of 3 is a very big negative. Okay. So we've marked the additional points, and now we're ready to look at the shape of the graph. And to draw that graph in, we'll have a look at the multiplicity of the zeros, and we'll look at the zero, the minus 1, the root or 0 of minus 1. That's a multiplicity of 5, so we know that's going to go from a negative to a point of inflection and then a positive. We've got the root of 1, and we know that that's going to just cut straight through. We know it's going to come from above, so we know what shape that is through that root. And a root of, the final root is 2, and we know that that's going to come like a concave down because it's coming from below, because we know where these other points are as well. So let's just try and draw that in. We're coming up towards the 8. We then come down through there. We go down here, back up to the root, come back down, and then it's a very long negative here, and we go, although I haven't done it through that X, you can kind of see that it goes way, way down, negative minus 4096. So that's broadly the shape of the graph. I'll just tidy that up a little bit so that you can see that. And let's have a look at GeoGebra, and I've typed it here in GeoGebra. we've got minus 2x minus 2 squared, x plus 1 to the fifth, x minus 1, a lot smoother, but still the same features and a slightly different um, scale, but still very much the same features. And you can see it goes from very strongly negative, it goes through that point, the y-intercept at x equals 0, y equals 8, and then turns back down. And although it's harder to see here, you've got the end shape to the concave down at that 0, x equals 2. So there we go.